Good morning, good afternoon, and welcome to this conversation on the changing role of wireless in the enterprise. And this is a report by Cel-Fi in collaboration with RCR Wireless. And today I have with me Werner Sievers, is the CEO of Nextivity. Werner, thanks for being with us today.
Hi, Monica. Pleasure to be here.
Can you tell us what is that Nextivity does in this area?
Absolutely. Nextivity is focused, frenetically focused, if I could put it this way, in providing in-building wireless solutions to its customers. Those customers are carriers, enterprise companies, large and small, and even residential customers. And the sole purpose of doing that is obviously to participate aggressively, forwardly, if one could put it that way, in this whole densification process that we hear being spoken about quite regularly. And of course, that insinuates dealing with black holes, dealing with areas of poor signal quality inside of buildings, which some people refer to as that last sort of frontier that the operator has to cross, right? The macro network exists. There's enough macro signal, generally speaking, in most countries and most cities, but the in-building context where the majority of phone calls are made, many of the data-orientated calls, cellular data calls are made, is the number exceeds 70% of all calls actually originate indoors, really is that last challenging environment that typically the operator has tried to deal with, but obviously hasn't really been that successful in a sense. And in trying to deal with it, they've tried to subsidize big DAS systems in large enterprises over the term, and that doesn't make financial sense. It doesn't work from an ROI point of model for the operator. So many technology companies are stepping into this middle price space, which are all the in-building wireless opportunities, let's say less than 500,000 square feet, where we're vying for a position in solving the in-building cellular deficiency.
Yeah, and as you say, we have conquered the outdoors, but the indoors is still not quite there yet. And but why now? Why is it that there is all this incredible growth in the interest in in-building coverage? Why now? Why not 10 years ago?
Yeah, I mean, good question. And I think 10 years ago, or 5 years ago, 2 years ago, there was still a significant amount of infrastructural development in the macro network, and number of operators, many operators were focusing on building out their macro networks. In the in-building sense, all the large venues, the large buildings were being plumbed for digital air, if we could put it that way. And those were happening very often with the full subsidy or financial involvement of the operators. Today, many of those large venues, the large public buildings, obviously the sports stadiums and many of those kinds of marquee venues have almost all been plumbed. All the important ones have been plumbed. And so what one now sees as a directive that focuses more towards this in-building space that isn't of the same marquee value, firstly, and secondly, isn't of the same size. And that is this middle price space being hot. So in answer to your question, firstly, there's a preoccupation elsewhere. There was still work to be done in the macro network. The big buildings slowly began to become plumbed. Digital air was available. And ultimately what then was remaining was a category of buildings that couldn't be financially serviced, the offerings, the technology offerings were as such that really they didn't make commercial sense, financial sense for building owners, for lessees, for lessors. Now that has changed. As this new wave of densification technology unfolds, it becomes affordable from an ROI model point of view. And as a result, I think, one sees this energy that is taking place in the in-building space right now, which wasn't occurring before. Also, I think there is some maturity and cost reduction in the signal source. In other words, the BTS or the small cell for capacity considerations. That technology really wasn't readily available 5 years ago, 4 years ago. certainly not on a do-it-yourself or self-install enterprise model. That enterprise model is now sort of unfolding, and it's slowly maturing, and ultimately in the future, it should be a successful model for the operators.
Yeah, and you talk about the middle price, and that's most of the buildings belong to, or most of the venues belong to that category. So that's not just the exception; it's actually more of the rule.
Right.
What is that distinguishes them in your view in terms of the requirements they have? Cost is clearly one of them, but what else? What makes them different from the big, large venues?
Yeah, I think it's, obviously size and the nature of the building. So there is a loosely termed category which really would define that middle price context at sort of less than 500,000 square feet. We'll probably find that over time, that number reduces to perhaps, 4,000 is the average, and then 400,000. And then perhaps it even reduces further as those buildings get serviced, down to a lower number. But the reality is that cost, I think, has been, the single largest implication, largely because there's been no way to justify the cost for a classic middle price building. And the other reality is that I think the value for an owner of a building, the value for a developer in terms of, preventing or slowing the churn of tenancy wasn't such a high priority. Now there is a recognized consideration that says buildings are more valuable if they're plumbed for digital air. You can charge a higher lease or rental on these buildings. And most definitely, it's now an accepted fact that the tenancy is more protected. So I think the fact that, there's a growing awareness of our digital life and our digital context, and the fact that cellular, as opposed to perhaps Wi-Fi only or Bluetooth only or other forms of short-range wireless technologies, is key to having an omnipresent signal. And so if one looks at it from a cellular point of view, it's taken a while to get the cost of cellular to a point where one can now add value to a building at a cost which, classically, as I mentioned, was serviced or provided by an operator. That burden now more and more falls on the enterprise. And as a result of it, more and more of the enterprises are taking a proactive position and leveraging their value in the building.
So what are the options available to a small medium enterprise to get coverage in addition to Wi-Fi?
Yeah, I mean, there are a few classical routes to follow, and those include smart boosting technologies, which will service up to, say, 15,000 square foot. When you sort of exceed the 15,000 square foot and you want to go to 50,000, 100,000, maybe all the way to 500,000, the classical structure or architecture has been sort of the distributed antenna system or DAS system. Those have classically been costly, particularly for those large marquee public venues that we've mentioned. And now, however, companies like ourselves and others are introducing platforms or classes of technology which enable the function, the benefit of DAS systems, and bringing those down to more of a middle price context, both in function and in cost, and in terms of the caliber of installers that are required to install these systems. So I think, if it's coverage, that's the primary problem. One can look at an outdoor source, signal source, off air. However, if there is a capacity deficiency in a building, the other product that is taking a preeminent position is obviously a small cell. And normally what one would look to in any opportunity, you'd look to see whether you could service the in-building requirement off air using the macro network as your signal source, or make a calculated decision about whether you'd be best served, or the enterprise, the customer, would be best served by bringing in capacity. And in that case today, more often than not, for the middle price, you would look to a small cell to serve that need.
Yeah, and so, but what you're doing is somewhat of a different take on all of this. It's a third way to go.
It's a third way to go, and it's this hybrid mode that I think we've discussed in the past. And classically, what we are is we're a hybrid between a smart boosting class of technologies and an active DAS. Active DAS being the high-end, all-digital, quasi-self-organizing infrastructure. And we're taking a hybrid approach where we're combining 10 years worth of experience in smart boosting technology and being partners to now over 200 operators around the globe and many enterprises in North America. We've taken that sort of experience and the benefits that are derived from that class of technology and driven a sort of a hybrid version of this smart boosting platform with all the benefits of active DAS. And that enables a middle price to get the benefits of a classic active DAS, but at a much more affordable level of cost and not an element of simplicity, but affordability and sort of ease of install.
So let's step back for a second. So what is the difference between what you propose, your solution, and an active DAS or passive DAS?
So a passive DAS is traditionally a coaxially driven head-end device, and they are remote passive antennas. They're not powered, and the system needs to be well engineered to accommodate the losses that typically are inherent in that architecture. So it requires a good amount of planning, needs experience to install it correctly, and it can serve large areas, but it obviously has a per square foot cost associated with it. Active DAS systems have come along. They've extended the functionality. They've included fiber. They've added levels of management overlay. The antennas are active in the sense that they can respond more intelligently to signal circumstances in the local domain of the antenna. And so what one really sees there is a migration away from the legacy or classic DAS more towards the benefits that are derived from an active DAS. And as I've said before, the main implication for the slower growth, should we say, of active DAS has largely been the cost, that a middle price hasn't been able to derive the benefit of an active DAS simply because of the cost and the engineering implications of installing that. What we're doing is we're saying we can provide cellular benefits, coverage benefits to an enterprise anywhere from 15,000 square feet all the way beyond 200,000 square feet without being burdened architecturally from a cost point of view to be able to scale that large. So we have a very unique platform, which, as I said, we've developed over the last 10 years, which enables us to be cost effective and appropriate at the sort of 10, 15, 20,000 square feet. And we use that same essential platform to migrate all the way up to, the 500,000 square foot classic sort of definition of a middle price. And that, it's a very busy space. It's really a rewarding place to be right now. And of course it has two implications. One of which is, depending on the venue nature, the personality of the building, depending on the structure, the construction material, an off-air signal may very well be adequate to serve that building need if it doesn't have a high population of devices, whether those be smartphones or sensors or cameras, video cameras that are transmitting high-def video. Then one can sort of do this in an off-air context where the signal source comes from the macro network. However, in many buildings today, there is a capacity deficiency, a macro capacity deficiency. It's not possible to serve the signal from outside in, and you do need to serve it from inside out, i.e. a small cell, in which case we would advise our customers to bring in a small cell from their carrier, whoever that might be. And then what we do is we take our system, our hybrid system, termed Quattro, and we couple that Quattro system to the small cell. What that does is it effectively takes the capacity of the small cell and makes it uniformly available to, every nook and cranny, as it were, in the venue space. And that's what's turning out to be, so successful for us.
So you're basically managing small cells. So it's a complementary solution to small cells.
It is. We're a very tightly coupled partner to small cells where there's capacity required. And in many venues today, in fact, the majority of in-building installs worldwide, I would say, in the middle prize, are still non-small cell driven. That will change, is changing and will change. But the reality is there are a tremendous amount of off-air installs that are done. And as long as they're done by qualified and skilled installers or system integrators, they're very appropriate for the need. So in many instances, it's a warehouse, a large venue with a low population of, should we say, mobile devices. It perhaps has other machine-to-machine devices which you're needing to serve. But generally, you can serve 1 million square foot of warehouse space with a properly designed off-air system, and typically our Quattro system would do exactly that. However, you might have an enterprise environment with 300-400 people, and that is a very risky endeavor to go and use an off-air signal. So in that case, we would partner with whatever small cell is the operator's choice of small cell at the time, and that typically would enable us to, as I say, uniformly provide access to the entire building through the auspices of this distribution architecture of ours called Quattro.
Yeah, so how does Quattro relate to solutions like, there are new hybrid models for small cells that try to overcome similar problems?
Well, firstly, we don't deliver, there's no small cell component built into Quattro. So Quattro is always the coverage partner to a solution that has an inbuilt signal source, let's put it that way. If you have a look at, there are a number of DAS class vendors that have their own inbuilt small cell or signal source. And those, of course, tend to be on a very much higher end cost per square foot. So really what we're saying is that the operator generally is the decider of which small cell has been approved, which small cell gets supplied or provided to an enterprise. Our job is to partner with that small cell and do the best possible job about providing the coverage component. So the partnership between ourselves and, should we say, an Alcatel-Lucent or any other brand of small cell really comes from the mating of Quattro with this particular small cell, which makes it quite different. There are other, should we say, BDA-based platforms that can also, they're not hybrid by any means. They have passive antenna. They're more like the passive sort of DAS components. They tend not to be ideal partners for capacity with small cells. So I think our strength comes from our relationship with operators. We're finely integrated with, as I say, 200 of them around the world. We understand their small cell strategy. We understand how they prefer to see buildings plumbed or digitized. And in that regard, our technology offers a very flexible, both from an installation burden or labor content point of view, as well as from the actual equipment cost point of view. And then, of course, it's all managed through a cloud-based management system, which enables, either the operator or the enterprise or a group of enterprises. You can substruct how that works, enables them to sort of keep track of devices, of buildings, of performance levels, et cetera, et cetera.
Now, one thing that it's quite interesting about your solution is that you have, basically, it's a new concept of what a cell is. We used to have antenna, that's a cell, standalone, that's our, and you somehow are moving beyond that concept. Can you talk a little bit about what's the trick there?
I think today you have to use all the tricks in the bag, right? I think our trick and hopefully trick has an interesting connotation to it. It's probably a trick is something you can get away with for a short period of time until somebody discovers that it's a trick. And I think the way we look at things is that small cells are great capacity adders. They are an absolute inherent component of this ever-growing HETnet. But there are implications for the business model with operators. Operators today want to develop, mature their self-install small cell, their enterprise small cell program. This is not that trivial. And, you know, we work closely with them so we can see how much effort it's taking to kind of mature this program, where essentially an IT person in an enterprise can request a small cell as a capacity adder. Now, small cells don't necessarily always provide the best coverage footprint. They are a great capacity adder, but they can sometimes be a very modest coverage adder. And if we're speaking the IoT, we know the IoT has zero meaning unless one's within coverage, right? Coverage becomes the essential component for the IoT. So how does one ensure that you can take the benefit, the capacity, in other words, of a small cell and make sure that literally you can extend that or you can make that capacity available to each location inside of the building? So we're in favor of creating supercells. And the supercell is created when you take a small cell and you mate that or you connect that to a Quadra system. What that really does is it massively increases the footprint of that capacity and limits any potential interference. Of course, what you could consider doing is if you have a large enough building and a single small cell doesn't give you the kind of footprint that you require, you could consider multiple small cells. However, a multiple small cell install is far more complex, far more risky from an inter-small cell interference point of view than a single installation is. So by using a single small cell and using Quadra as a partner, we're able to create these oversized or supercells which eradicate the design skills that are needed to take a multi-small cell solution, install it without any inherent sort of technical details, and in particular, interference-related issues. So the other thing is that when you create a supercell in a building, it really does enable that building to be densified. What I'm saying is that in many installs that aren't done well, you end up in a situation where some of the devices, they could be cell phones or other devices, in a building aren't all looking to the small cell. Many of them perhaps are still looking to the macro network because in parts of the building, the macro network is actually the stronger signal. So you really want to make the small cell dominant in a building. If you make the small cell dominant, the likelihood that all the devices in that building will look to the small cell as their capacity is much greater. And that is more in keeping with offloading capacity from the macro network, which is, of course, what everybody wants, not only the operators. So assuming you have a substantial enterprise-grade DSL line or some ISP connection that can take the capacity that obviously the small cell would utilize on the backhaul, it's a fine way, it's the best way, it's the most risk-free or risk-averse way of creating true densification in a building without any of the risks of interference. And often, depending again on the skill of the installer, interference isn't always obvious. So to be able to detect this interference and design around it isn't that simple. And in some buildings, because not only of the building materials, but because of the architecture of the building or the format of the building, for example, a narrow, very long building is not something that you can simply just design around or put multi-cells in without creating some concern about interference. So there are many, many good reasons to consider a supercell rather than a multi-small cell environment. Of course, if you have an exceptionally large building across multiple floors, you would obviously bring in multiple small cells. But then what you would do with those small cells, you would extend each one of them and create a supercell, multiple supercells, which by virtue of the nature of what Quattro does, it will protect the various supercells from inter-supercell interference, if I could put it that way.
So basically, it's a very different way to think about coverage, to think about even planning and how you organize and manage traffic in that kind of environment. It's not just, you know, like what we currently have, for instance, with Wi-Fi or with macro networks. It's a more of a ubiquitous kind of coverage.
It is. It is. I mean, I think, you know, often we get asked about, you know, what exactly, well, perhaps I shouldn't sort of preempt too much of that comment, but if one considers again the IoT and the nature of the IoT, it suggests that there is digital air everywhere. Otherwise, if you're outside of that area, you're not participating in that digital economy. And, you know, we feel that our remote units, which are part of the Quattro system, sometimes referred to as remote radio heads by some architectures, but if you just see them as remote units, they're out there very intelligently summing up the situation and creating a self-organizing environment, which means that the installer can very readily get the main architecture in place and then very readily test to see whether or not there is a very high degree of coverage. And of course, more and more, you're wanting to literally cover every nook and cranny as opposed to, you know, just covering, you know, a modest swath of a building or a floor. You're being forced to deliver, particularly to somebody who is charging for the value that is being created by the digital air in their building. You have to be able to prove that your coverage is pretty omnipresent in a building, and to do so, you need the flexibility and the wisdom from a self-organizing point of view that a product like Quattro has.
Yeah, so this is a quite interesting development. So what is it you're working on right now as you move forward? What's the next challenge you're going to take on?
Well, I think certainly as we look at IoT and the implications of boosting IoT signals, which have a different context, different personality, we will continue to follow a very strong LTE route. So we will follow the standards for IoT from an LTE derived point of view. We know that these LTE signals that service narrowband applications have better link budgets, so they do actually have a better propagation personality or capability. But even so, we find now that to get coverage that will really address the IoT, one's needing to get these remote units down to a size and a cost where they truly can service an even more granular approach to the sort of indoor coverage context. So we're working on a set of solutions, features for our platform that will economically serve the IoT space. And then we're also looking at putting more capacity into the links between our remote units, which I think you're familiar with, happen to be power over Ethernet. So our infrastructure is not coaxial, it's not fiber, it's power over Ethernet. It gives us a great advantage out in the remote ends where we can now position our units to optimize coverage, not because of the fact that they're adjacent to power outlets or the like. So it's all aligned with what we're doing there. And then making Quattro as responsive to the zone movement in small cells in the macro network. So if the, if the hybrid active DAS system can be more responsive to what's happening in the greater network scheme of things from a zone point of view, those are the kinds of things we're working on today.
Mm-hmm. Well, that's very exciting, and we look forward to follow you along this path. Werner, thank you so much for talking to us today.
Thank you very much, Monica.
And this was a conversation for a report on the role of wireless in the enterprise by Cel-Fi in collaboration with RCR Wireless. And thank you all for listening in and watching the interview.